Okay, so for those of you who are aiming for skill or higher, well, definitely try this one yourself first. Anyway, so let's quickly go for this. So for this, we're going to pretty much do the same thing as the previous two examples, except this would be a bit more complicated. So we're going to combine all the logs, log base 2, log base 2, log base 2. So this time, we're going to reverse the process. So we bring the 2 back here as the exponent. So you can write this as log base 2 12 square, and then there's nothing you can really do here, so minus log base 2 of 6. Well, I mean, you may find this redundant, but it would be easy for us for the next step to look at what we need to group together. Okay, minus, so same thing, put this back here, it becomes the exponent. So you have log base 2 27, 27. So 27 exponent of 1/3. That means you take the cube root of this. Okay, so let's simplify this further. So 12 squared gives you 144. So log base 2 144 minus log base 2 of 6, and then log base 2. So if you take the cube root of 27, that gives you 3. Now they all have the same base. We can combine this, and this together. So if you look at this, we have divide. So log base 2. So 144 divided by 6, and then divide by 3. You may want to put the 3 on the bottom, but it's the same as putting the 3 here. Why can't I do that? Let's do it outside here. So 144 divided by 6 divided by 3 is the same as 144 over 6 divided by 3, which is the same as 144, because I remember some of my students in 30-1 last semester, they were having some issue visualizing this. 144 over 6 divided by 3. Divide means you can write it as times 1/3. That means you have 144 on the top, 6 on the bottom, 3 on the bottom, like that. Okay, so now all you have to do is combine these numbers together. So log base 2, 144 divided by 3 divided by, 144 divided by 6 divided by 3. Make sure when you punch into your calculator, you do 144 divided by open bracket 6 times 3 close bracket. If you try to do 144 divided by 6 times 3, you would not get 8. So this should give you 8. And then I hope you can see that 2 and 8 are related in this fashion. So log base 2, you can write 8 as 2 raised to the power of 3. And then as you can see, same base for log, same base for exponent. Cancel them out. So that means my final answer is 3. Of course, now you can check your final answer by plugging all this into your calculator, and you'll see that your answer is 3. Okay, so next one, write as a fully simplified single log. So that means we are going to combine this all together, right? So if you look at this, they are all log base 7, so that's good sign. Now let's do this. Hope you can see that there's nothing you can do here, so skip that. log base 7 of x squared, and then there's nothing you can do with the second term as well, so leave that as log base 7 of x. And then for the third term here, you take the coefficient back here and make that an exponent, so minus guys, be careful, there are two terms here. This is one term. There are actually 1, 2, 3, and then a fourth term. So move this here as an exponent, minus log base 7 x raised to the power of 5/2. And then last but not the least, plus 2. Now, if you think about this, do you think it would be a good idea for me to simply leave the 2 like this? Because the thing is, 2 doesn't fit into any of theirs. They all have log base 7. So that means it might be a good idea to somehow convert this into something that has a base of 7. I mean log base 7. Okay, so let's erase this. How can I do that? Okay, now can you write that as, well, I want log base 7. Can I write that as log base 7 square? Okay, you might be wondering what's going on. Remember, if we have something like this, same base for the logs and same base for the exponent, then we can cancel that out. Now what do we end up with? 2. So that means instead of having just 2, I rewrite that as log base 7 of 7 squared. Alright, so now if you look at this, everything is in terms of log base 7. So this, and that. Now I can combine everything. So, oops, wrong color. So log base 7 and then something big here. So for anything that adds, we multiply them. So x squared times x squared times x times here. You can convert this into 49 if you want. So let's leave that as 7 squared so that you are not confused. And then this one's minus, so you do divide. So x raised to the power of 5/2. Now we can simplify this further. So log base 7. So x squared times x gives you x cubed. X cubed times 7 squared, 49 x cubed. 49 x cubed. And then on the bottom, there's nothing you can do. You still have x raised to the power of 5/2. And because we have x on the top, x on the bottom, we can apply the exponent law. So log base 7, 49. So you subtract the exponents, 3 minus 5/2, which gives you 1/2. Alright, so next one. So if you look at this, same thing here. We accept different numbers, different variables. So in this case, if you look at this, we have log base 2 of this minus log base 2 of that. So minus, so that means we can do divide. So log base 2, one big thing, divide. So this on top, x squared minus 9 on top, and then on the bottom, x squared minus x minus 6. Okay, now I hope you can see that we can actually do some factoring. This is the difference of square. this is a perfect square of 3. So this is basically x squared. Well, let me just write this. So this is basically x squared minus 3 squared. You can write that as x minus 3 times x plus 3. So x minus 3 times x plus 3. And then on the bottom, this is a quadratic. So coefficient is 1, so we can write this way. So find two numbers that multiply to -6 and add to -1, and they are -3 and +2. Now, if you look at this, x minus 3 on top, x minus 3 on the bottom. So that means the leftover would be log base 2 of x plus 3 over x plus 2. Alright, so last question. This is transformed from this. So you guys are English speaking, you should be able to see that you started from this and then after that it becomes that. If you find this confusing, then I suggest you guys to just simply write that out. So y equals to log base 3x is transformed into y equals to log base 3 27x. Even though this is the first time we talk about log transformation, well, actually we have not even talked about transformation for logarithm, but based on what you have learned before, doesn't matter. Alright, you should still be able to apply that, so you might want to pause for a few seconds and see what is going to happen or what has happened. You might want to quickly look at the transformation general formula, which is this one here. Okay, so I'll just write it down here, the transformation formula. Oops, wrong color. Y equals AF B times X minus H plus K. Alright, so pause a few seconds and see if you can figure out what are some possible transformations. Okay, so if you look at this, log base 3x, log base 3 27x. So that means this one has an extra 27 here. If you look at this format, the number inside the function in front of x is the b value. What does that tell you? That means this is the b value. Alright, so what does that mean? That means you have a horizontal stretch. So for this one here, first transformation we can think of is b is 27. So remember, we flip it upside down. So that means we have a horizontal stretch by a factor of 1 over 27. Let me be a bit more explicit here about the y-axis. So that means your graph is actually narrower. Okay, I'm sure most of you, if not all, figured out this. That's obvious. But now, what is the second possible transformation? So this is what has happened. X becomes 27x. And we already addressed the 27 here as a b value. So what is the other transformation? Right? So you might want to think about what you learned today. Maybe the product law. So if you have no clue, then never mind, I'll quickly write it out for you. So if you look at this, let's rewrite that. Y equals to log base 3 of 27x. So if you apply the product law, then you can write that as log base 3 of 27 times x times x, and then I can split that up as log base 3 of 27 plus log base 3 of x. If you find this confusing, you can put a dot there for multiplying. Now, if you look at this, we can simplify this a bit further. Hopefully, you can see a relationship between 3 and 27. So we can write 27 as 3 raised to the power of 3, right? So this would cancel out. So that means the final simplified form is 3 plus log base 3 of x. Now, if you compare this to this, oops, never mind. So log base 3 of x log base 3 of x. That was the original function. This is the new function. If you look at this, you can see that 3 has been added, or if you find it confusing, put the 3 behind. So let's rewrite this. Log base 3x plus 3. Now what does that tell you? Plus 3. This is outside the function and comes after the function. That means there is a vertical translation of 3 units up. So I'll quickly write down here. Vertical translation of 3 units, or up by 3 units. Okay, so I hope you don't find this lesson too bad. Well, enjoy these questions.